Welcome to the second lesson in Chapter 4 of the Pearson video series. Lesson 4.1 discussed congruence, and Lesson 4.2 discusses congruence in the sides and angles of triangles. Theorem 4.1 says if the sides of a triangle are congruent, then the angles opposite are also congruent. The converse says if two angles in a triangle are congruent, then the sides opposite are congruent. So if we take a look at this triangle right here and we label it, these two sides right here are the sides or the legs, and then the third one is the base, and then the angles on each side of the base are called the base angles. And then the third angle is called the vertex angle. If two sides of a triangle are congruent, the triangle is isosceles. So down here we have a picture of an isosceles triangle, and since the two sides are congruent, then we know that the opposite angles are also congruent, and those are the base angles. And then we have an equilateral triangle. An equilateral triangle has three sides that are congruent, and based on the converse, we know that if the three sides are congruent, then so are the three angles. And if the three angles are congruent, then we call it equiangular. And an equilateral triangle is always going to be equiangular, and an equiangular triangle is always going to be equilateral. And since we're talking about triangles, we know that every triangle, the angles measure 180 degrees. The next theorem, Theorem 4.2, says if triangle ABC is bisected, that means cut in half, at the vertex angle, the side opposite, the base, will be bisected. So right here, here's our vertex angle. And if it's bisected, which it's marked that it's bisected, then we end up with the base cut in half. And so this base is marked as two congruent parts. Okay, so let's look at an example. Now that we know some important properties of triangles, we can use what we know to set up an equation. Okay, so looking at this one, we know that these two sides are congruent. That makes it an isosceles triangle. And in an isosceles triangle, the base angles are also congruent, which means that this one's 28 degrees, so this one must be 28 degrees. We already said that all of the angle measures add up to 180, so we can set up an equation that looks like this: 5x plus 9 plus 28 plus 28 is equal to 180. And then we can simplify. If we add these three up, we're going to get 5x plus 65 equals 180. Subtract 65 from both sides, and 5x equals 115. Divide both sides by 5, and we get x is equal to 23 degrees. Okay, let's take a look at the second one. In the second example, the sides are the same, so we know that these angles are the same. We don't know the third angle, so we can't set them equal to 180, but since we know these angles are the same, we can set up an equation that looks like this. Negative 4x plus 9 is going to be equal to 8x minus 3. If we add 4x to both sides, that one disappears, and we're left with 9 is equal to 12x minus 3. If we add 3 to both sides, we get 12 equals 12x, which means that x is equal to 1. And that's using the properties of Theorem 4.1 and 4.2 to set up equations. We can also use the converse of Theorem 4.1 the same way. If the base angles are the same, then we know that the sides are going to be the same. So we can set up an equation that looks like 8x minus 1 is equal to 4x plus 5. We'll subtract 4x from both sides, leaving us with 4x minus 1 on the left and 5 on the right. Then we can add 1 to both sides. 4x equals 6. Divide both sides by 4, and we get x is equal to 6/4, which is 3/2, or 1.5. Okay, in the second problem, it says, what are the lengths of all three sides of the triangle? To figure that out, we simply plug in the value we found for x. So we can say 8 times 1.5 minus 1, and that's going to be equal to 11. Okay, we can do the same thing with the other one. It kind of works as a nice check. So 4 times 1.5 plus 5 is also 11. And then finally, 2 times 1.5 plus 11 is equal to 14. So we end up with side measures of 11, 11, and 14. Okay, now, Theorem 4.2 describes the perpendicular bisector in a triangle. Looking at the figure, what can we determine from what we are given? Since the sides are congruent, the base angles are the same. Here are base angles, which means that both of these are equal to 31 degrees. If we know that both of these base angles are equal to 31 degrees, and the whole triangle adds up to 180, then we can subtract 180 minus 31 and 31, which is 62, and we are going to be left with 118 degrees, which means that this angle is 118 degrees. That being the case, RSQ is bisected, or is the bisector from RSP. So if we take half of 118, so 118 divided by 2, that gives us an angle measure of 59 degrees. So each one of these angles is going to be 59 degrees. Okay, now if we want to figure out what PR is, we know that this is 4, this is bisected, so this is also 4. PR is all of this added up, which must be 8. So PR is going to be 8. Okay, looking at this proof, see how much you can do on your own, and we will check it in class. Let's look at one last part. This involves the angle measures. So when you look at a problem like this, you want to see how much of it you can figure out without even starting on the problem. So looking at MNP, this is an equilateral triangle, also equiangular. So 180 divided by 3 gives us angle measures of 60 degrees. So we can go ahead and put 60 degrees in each one of these. We want to know what angle PNO is. That's this one right here, which is part of a linear pair. So if all of this adds up to 180, then we can subtract out the 60, and we've got 180 minus 60, and that's going to give us an angle measure of 120 degrees. Okay, so we can go ahead and fill that in. This is a vertical angle, or the vertex angle, in an isosceles triangle. So that means that both of these are the same. We don't know what those are, so we can call them x. And if we add this angle and this angle and this angle together, they equal 180. So that means 2x plus 120 is equal to 180. Subtract the 120, and 2x is equal to 60, which means that each one of those base angles is going to be equal to 30 degrees. Okay, using the same algebraic logic, see if you can solve these other two problems, and we'll check the answers in class. See you later.